Hello everyone, good evening. We were solving the questions from BSDS exam ISI 2024, right? The sample papers. We had done till question 5 in the last video. Now we will be looking into question 6. Question 6 is a bit complicated because it involves combinatorics as well as functions. See, the main concept here is not of functions. It is just based on permutations and combinations. The functions are given there to make this problem a bit more confusing. All right. It could have been done using objects also. The same concepts would have applied. But since we are dealing with functions, you might be a bit confused about which type of functions you are going to apply. There are not many concepts related to that, so we just have to stick to the combinatorics part. So I will explain this sum with an example, but please make sure that if you do not understand it, just rewind it or slow down the video and watch it again. All right, and if you have any questions, do put them down in the comment section. We will have a look into it. All right, so what does the problem say? The problem says that the number of functions f from 1 to 100 to 1 to 100. All right, so these ranges and domain are the same, right? So these are integers from 1 to 100 such that fx not equals to x. So when it goes from the domain to the range, it does not map to the same value, but it comes back to the same value. All right, so if I take an example, let's start with 1. Okay, so example. So if I start with 1, 1 might map to 2, 3, 4 till 100. Anything but not 1. All right, and it should map back to 1. Right, so there are a few choices here. Now how do I get the ordered pairs here? Because that is what we have to calculate, right? To get the number of ordered pairs, we have to fix the concept that we are trying to do. That means each element in x is mapped to a different element in fx. Just as I told you, one element from the domain goes to a different element in the range. All right, now f of fx equal to x, which means the composition of f with itself. Hear it carefully. Composition of f with itself means f of fx is the identity function. Okay, so it returns to the same point, just as I showed you in the example. Right, now what is the cycle here? What is the length of the cycle? The length of the cycle is just 2 units, right? Because if I apply the function once again, you can clearly see that if I apply the function once again, it will go to something that is again not equals to x, right? Because this will apply again. So I cannot calculate f of these things are invalid. Okay, so let us not waste any energy discussing these. So we are just looking into 2 cycles. All right, remember that. That will be important because you can see a lot of 2's here. So you know that when you have fixed the concept of 2 cycles, right? So what are the things that we have fixed? First, f of fx is identity function, right? That is done. We have 2 cycles only, because other than that we wouldn't get back the identity. We would have to go back to 4 cycles. All right, so since we are not asked that, we should keep it up till 2 cycles only. Okay, now let us start the counting, because combinatorics problem, all you need to do is counting, right? Combinatorics is completely based on the counting principles. So let us study the counting. Now while we are looking into the counting, let us look into some points. So how will we do the counting step by step? So first you choose a pair x comma fx for each x. Okay, I'll describe each of the steps. So step 1 would be choose x comma fx. All right, that will be one pair. You have to do this for each x, right? That is given. Now how many of these are possible? So from standard permutation rules, you know that 100 factorial of these are possible, right? That is hopefully clear to you all. Now each pair will form a cycle. So there are 100 choices for fx for each x, right? So that is how we get 100 factorial. However, if x maps to y or fx, then fx must map back to x, right? Fx must map back to x since the cycles are of length 2. So once we choose fx, we have no other choice for f of fx, which must be x. Therefore, the number of valid functions is same. Just look into this statement and understand it. The number of valid functions is same as, what is the concept here? The number of ways to pair up 100 elements into 50 pairs without repetitions. 100 elements, because 100 elements will go in 50 pairs, right? Because pairs of 50, each pair has 2 elements, so 50 into 2 in 50 pairs without repetition, because each pair will have 2 representations, right? You can have 1 comma 2 as well as 1 comma 2 from the domain and range, as well as 1 comma 2 from range and domain. All right, they will go back to the same thing. So what is this? How can we divide 100 elements into 50 pairs? So this is given as 100 factorial by 50 factorial. Now if we remove the repetitions from each pair, we will get 100 factorial by 50 factorial into 2 for each pair. How many pairs are there? 50 pairs are there. So that is option A. All right. So the explanation was a bit complicated because the sum was itself a bit tricky. So please make sure you understand the concept. I have written the steps as much as possible. This sum was more a matter of thinking about the problem, less a matter of solving the question in steps. All right. So I've written as much as I can on the blackboard. So please make sure that you go through the steps. If you are confused at any point, pause the video and re-listen to the explanation part that I gave it to you earlier. All right. So the correct answer will be option A, 100 factorial by 50 factorial, because 50 pairs and we are removing the repetitions from each pair. So that will be divided by 2 to the power 50. Why 52s? Because each pair has one repetition, right? So for each pair, I'll divide it by 2. So that will be 2 each. So how many twos? 52s. Not 5 to 52, but 52s. Okay, so this option is done. This question is done. Now we will be looking into question 7 in the next video. I hope you all have understood this one. Slowly the questions are becoming more complicated. But then again, sometimes you will get a question like the last one, question 5, which was a bit simple. All right. So see you all in question 7. Bye for